Okay, today is our first day meeting lectures for the SMJP1022, okay, which is experimental method. Okay, today is just an introduction of our course. So I will go through from the beginning. Okay, first of all, we need to understand our lecture first. So I would like to introduce my name. I'm Dr. Hafizal bin Yahya. Okay, from the Department of Mechanical, okay, Precision Engineering. So actually, I'm sharing with Dr. Azmah with this course. Okay, so for the first half, I will lead this lecture. Okay, and then followed by Dr. Azmah, a second half of this lecture. Okay, actually, we have our lecture on Wednesday, 9 a.m. until 9:50 a.m. So, and then at the same day, today we have our virtual lab. Actually, later on, I will discuss on the virtual lab. So, according to the timetable, we will start at 2 p.m. and finish at 4:50 p.m. Okay, actually, this is the timetable for the real experiment. Okay, we just slot the time so that you have uh, the lecture according to your timetable. So for the meantime, due to the coronavirus, so we have to decide to use a technique of virtual lab in order to finish our course. Okay. So after this, I will discuss more on the virtual lab. Okay. Actually, according to our timetable, our courses, we will start on week 1. Actually, last week, this is week 1. In this course, the whole course we will follow 14 weeks lecture or 14 weeks meeting. So we have a week from the week 1, which is last week. So now is in the week 2. So today, uh, in for the lecture, actually we have a lecture meeting for 1 hour only for the subject of 1022. That means we have 2 credits, 2 credit. So the not a quite high credit if compared to a 3 credit. So that means we need to less time if compared to the 3 credit hour. Yeah. So this is a 2 credit. So that means according to the timetable, we have 1 hour lecture, and then we have a 3 hour labs. Okay. Yeah. So for the labs, later on I will discuss. For the lecture, we have to have a meeting of 14-hour lecture. Okay, 14 hours lecture. So for the 14-hour lecture, from the previous normal activity before coronavirus, we will meet face to face, okay, in the class. So we will do activities like student-centered learning. So I will give uh, like kind of topic. So we will discuss based on the our course. Okay. So and then at the same time, I will use a lecture-centered learning. So the lecturer will deliver the information. Okay. So due to the coronavirus, we will have to tune a little bit. The contact supposed to be in face to face, but we will use a face to face via online. Yeah. So that's mean not all the material can be delivered by online. Maybe due to the some of you is not available due to the bad connection of the internet or something. So some of you from the international student which is not stay in Malaysia, already in their country, so a little bit time difference and cannot face to face via asynchronous online. So by this, we will just a little bit tuning to the setup of the lecture. So that's mean face to face, maybe by using a slide. Okay, time you spend your time reading the slide. Okay, and also I record. Okay, and then I publish, and then later on you will check it back or as a reference. Okay, so we have week number 1 until week number 14. So along the way we have the break time at week after week 7. Okay, we have a week 7 on December, the first week of December. So the second week of December, which is the mid-semester break. Okay, for the mid-semester break, this is 1 week, and then we continue our lecture. Okay, on week 8. So at that time, Dr. Azmah will take over this week until finish. Okay, so along the way, if we look at the week number 1 until week number 7, I will finish the course schedule. So for the course information, after this, I will call it CI for the course information, which is the course telling of the structured information of our course. Okay, from the name of the course, from the code of the course, and how long the course, and then who is the lecturers, and contact numbers or email, and of course you need to understand the course information. Okay, we call it course learning outcome or CLO. In this course, we have 3 CLO. The first one is CO number 1, CO number 2, and we have CO number 3. So CO number 1 actually, we have CO number 2 only. For the CO number 3, is basically the same thing, the same, which is work effectively in the team for the report. Okay, for the report, which is refer for the lab report. Okay, and then for CO number 1, which is explain basic concept of measurement, carry out precise reading in measurement, and apply statistical method to make an analysis and writing report. Okay, for the CO number 1 is basically focused on the lecture. Okay, I will give a lecture for the lecture consists of 14 weeks. So the content of the lecture is basically the information related to the measurement, related to the statistical method. Okay, some kind of formula can be used to calculate. Okay, this one a little bit calculation. Okay, so and then we have the information of measurement. What type of measurement? Let's say we have a pressure measurement, length measurement, we have a force measurement, and so on and so forth. Okay, so and then the level of the CO1 will be covered. Let's say we have number 1, KW is supposed to be knowledge. Okay, the level 1 knowledge, the student would be able to define, to describe, to write or something, and it's not up to the level number 3. Okay, as you can see from here, we have KW 1 up to number 3. So the level should be up to level 3. Okay, the level in the term of word would be a kind of analysis. Okay, a little bit higher. Okay, and then we have CO number 2 would be work effectively in team to conduct experiment. Okay, in this we will give, you will conduct an experiment. So in this case, the virtual experiment, later on I will explain. So in this CO2, we will look at the 2 category for PLO, would be program learning outcome, which is number 9. Okay, number 9. Okay, the student in this would be able to work in team, the first, and also the ability of the student to do a report. Yeah, there are two activities. The student will be able to work in team. So you given a lab, and then you will be in a team. Three of you will discuss together related to your lab activities, and then the second one is you will produce a report based on your activities in group. Okay, so I will give you a timeline for the report. Okay, let's say let's say the lab activities takes place in week number 4 or number 5 or something like that. So in 2 weeks time, you will able to submit your lab report in group. Okay, in group. So there is a lab rubric that we call it rubric, the structure of the point that we will give you according to the lab report. So that the lab report is supposed to be containing of information like uh, title, method, okay, the equipment that you use, okay, and then the data gathered, data analysis in terms of table, and then you discuss the finding. You need to draw a graph or something, and then you answer the question. So all those rubric containing marks, so that will sum up to be marks that used to as a coursework, okay, for the lab activities. Okay, so for the CO2, we will look at the number 9 would be work in team, and then the number 10 is ability to deliver in terms of communication. Okay, in this thing is communication can be looked at these two way by using verbal communication. Okay, but in this lab report, we will look at the way you delivered the writing style in. Okay, so so this one CO2 we will do from the lab report, and then for the CO1 is basically from the lecture. Okay, and then for the weekly schedule, we have week number 1 until week number 30, number 14. So along the way, we will cover the several chapter related to measurement standard unit, accuracy, precision, and sensitivity. So be chapter number 2, and then 2 weeks, 3 weeks, we will cover week number 4, 5, and 6, error and analysis. So there is several technique can be used to calculate the error, and also related to the statistical analysis. Okay, and then we stop there, uh, and at week 7 to 8, we have a mechanical measurement, followed by the measurement of force, and then we have measurement of temperature, and finally we have the measurement of pressure. And then in the course information, actually this one is I break down into several slides, so you can download by using our e-learning. I already upload it on our e-learning, so you can download course information. So information consists of assessment detail. We will look at the student learning time SLT. Basically, we have a lecture 14 weeks. We have 1 hour meeting. So total up would be 14 weeks, 14 hours. And we have all lab activities. Basically, we have 42. That means we have 14 times the hour. Yeah, would be 42. This one. And finally, we total up, we have independent learning, non-face-to-face due to the activities of the preparation, revision, or lab report among your group. And then total up to be 72. The rest by using lab report 50% and then final exam. Okay, total up to be 80. Okay, total for the 2 credit, which is 80 hours. Okay. So for the assessment detail, for the lab report, we have a 6 lab report. One is equivalent to 10%. We have 6 lab reports, so the total will be 60%. Final exam, okay, would be 40%. Due to the COVID pandemic, so we have a supplementary course information. This supplementary course information, same thing as student learning. Our this time will change a little bit of online learning, so we have to worry about this number. So this is due to the documentation only. So we translate it to be in live interaction by using how many slides we give a lecture. Okay, for the lecture, we will use online lecture. Okay, by using asynchronous. Okay, I know that some of you from the international student, due to time difference, maybe you some of from Egypt, from the little bit time different. Maybe here we at 9 o'clock in the morning. You maybe at the morning. So due to the time constraint, you have difficulty to attend the meeting. So I will use recorded. So this meeting I also record and then I will publish on YouTube. So and that URL I will attach on our e-learning. I will upload the information of the original PowerPoint slide. Okay, you don't have to worry. Okay, the PowerPoint slide I will give it to you on the e-learning, and also I will attach the video. So for the lab activity, then one is consists of 3 students. So we have 6 lab activities. For the 6 lab activities, basically activities is by right now our virtual lab is basically 6 virtual lab. That's mean represent for the one week equivalent to 1 virtual lab. So if you total up, we have a 6 week for the virtual lab. So that's mean we have 1.5 months. So that's mean we will maybe we in the middle of the or we will start in weeks number 7 or number 8. Along the way, from the week number 1 until week number 6, we don't have any lab activities. Okay, so we will week number 8, okay, and then we'll finish week number 14. Okay, it's depend on the availability of the virtual lab, because we are working out of the virtual lab activities. Okay, so maybe we will start week number 6, or it is according to the we are ready on the virtual lab. Okay. So the and during the activities we will record. Okay, we will record the lab. Okay, our technician will show you how the process is, and then you will gather the information, the data, and then you raise the data accordingly by using a table or what. So from there we will give a manual. Okay, so then and you will work up from the manual to produce a lab report. Okay, yeah. So 3 students in the group, so that you need to discuss what the manual is asking. So and then you produce the report 1 week's time or 2 weeks time. Okay, later on I will details on Okay, so this is the to record using our UTM Smart. Okay, our UTM Smart, I will capture the QR code and then I will uh, publish on our e-learning. Later on, I will not show this again in our slide. So later on, you will access to our e-learning. So I will publish the QR code on e-learning so that you access to the e-learning and you capture to record your attendance. Okay. So by using that, I will trace your attendance. Okay. And this attendance can be traced time you log in. Okay. What time you log in, very detailed so that I will record throughout the course. Okay. Okay, some of the lecture might not use this kind of QR code. It doesn't matter. Okay, maybe Dr. Azmah will use Dr. Azmah style. Okay, we will go through chapter number 1, which is measurement, standard, and unit. So actually, for the measurement, standard and unit is basically from the physics you've learned from the form 4, okay, or matrix. Okay, so this is quite basic. Okay, so basically, we'll go through very fast, okay, of this kind of standard unit, conversion unit, derivative unit, or something. So you can get more information from the basic physics textbook, okay, and fundamental of physics from the international textbook or something. So that one is very easy to access. Okay, so so a little bit introduction of the measurement is basically measurement is to the demand of measurement. So and then we measurement is due to the variable parameter you need to during the measurement. Let's say you have a length measurement, so you need to have some kind of information related to measurement, what type of measurement, by using what unit of measurement, and what are the tools that you need to observe to or to measure. So a variety of application takes place here, and also the demand of this measurement, so increase of development of instrument. Okay, so this as instrument would be a very simple instrument, okay, which is come from the tool or device used to do a measurement. Okay, from the simple one, we have a ruler, we have a veneer, okay, tool, we have a clock or something like that. So until we have the complicated instrument by using electrical, or we call it device, we can get the information to comparison of particular quantity. Okay, I mean uh, in by trial and error from in the early stage, okay, from the stone middle to the by using their technology. So from the very simple measurement they use, okay, and up to nowadays very complicated, very advanced measurement instrumentation. So can be used to application of engineers of the expectation in order to perform a very useful experiment, okay, and or to the instrumentation for experiment, and it's also used for the engineer to estimate accuracy of measurement. Okay, let's say you have a sample and then you want to measure whether the estimation is very accurate or not. Okay, and in order to interpret the experimental data, okay, and know the limitation, what is the limit of this measurement, okay, and then to verify the physical data rely upon experiment. Okay, and then mass production demand of precision measurement actually in terms of the uh, manufacturing. Okay, in the manufacturing we need to produce very mass product, so we don't want to wait any defect or something. So the measurement is supposed to be very precise. Okay, let's say in the quality control. So let's say you have 10,000 of product we will produce in one day. So you need to test the sample of the product. Not all the sample you will test, okay, because of the mass production. You will pick up randomly from time to time in one day or in one production line, so that you need to make sure that this product is suit for quality control. In the quality control, we have several type of quality control in order uh, from the product itself, from the measurement dimension of the product, from the working of the product. Okay, so we need to take randomly to test the product. So in mass production, we don't have error room for the error, this kind of error in order to test. So the demand of precision measurement is very high. Okay, all parts of any product must be interchangeable. So one product, okay, one product you test, and then randomly at any time in the along the production line, if you take another test, it will be the same. Okay, it will be the same. Okay, impossible that we will test all the product, okay, along the production. Okay, let's say 1,000 we need to test. Okay, along the way actually we have already test, but for the quality control we need to test it randomly in order to make sure that there is a precise accurate uh, product that we will produce. Okay, possible only through improved method of measurement. Okay, mechanical powered machine. So this one is related to the some of the method measurement we need to improve. If let's say we use this kind of method is there's a limitation, so we need to improve to get a better result. Okay, and then control and ensure conformity to every operation by accurate measuring equipment. Okay, this one is in the production line, so we need to make sure that the accurate measurement, accurate testing of the product. Okay, from the blueprint or from the what we the objective of our product. Okay, must have accurate tool to ensure lasting dependability, and produced from the quality material, carefully manufactured. Okay, so the accurate measuring tool result in work, okay, approaching perfection. Okay, if we make an accurate measurement, and finally we will get the very perfect output. Okay, ensure a supplied product within agreed specification. Okay, this one is basically discuss more on the quality control of the manufacturing. Okay, ensure number of unacceptable finish. So we would like to reduce the defect produced from the operation. Okay, so that every time we will have a random inspection. So the inspection we will produce a result. So that means the defect of the sample, we make sure that we reduce. Okay, so and then we will achieve the higher production output. Okay, to ensure specification satisfy customer in most efficient way. Okay, so that we will produce a very good product, so that the product is meet the specification of the objective, and also to our customer. Okay, the earlier measuring tool basically by using tool of very simple by using the body to estimate dimension. Okay, they use hand, span, foot, cubic yard or something like that. So they're not using a tool but using their own body to measure. Okay, let's say in Malay we have hasta, jengkal, okay, or something like that, depa macam tu lah. So that we use body measurement. So but along the way, by using a body measurement, basically is not very not accurate. So there is okay, your body measurement, your depa, your foot feet is not the same as uh, others. Okay, so the way to measure is not the same. So this one is quite bit estimation. So the use of a modern measurement by using a standard ruler, caliper, micrometer, okay, and also the electronic device is very useful, okay, in order to get a very precise, okay, very accurate measurement. Okay, nowadays they use computers, the electronic device, so that attached to the uh, computers and very easy to manipulate to get the data, and then we manipulate the data, we extract the data, and then we can get input. It's very good. Okay, this is the old school use. Okay, and then now actually the ruler, the micrometer, the all these also use. Okay, so now we have a micrometer, verniers by using a digital. Okay, so can have a 2 or 3 decimal point. Okay, okay, and then we go for standard. Every everyone that need to have a standard. So basically the length, the weight. So there is a certain standard to be in the benchmark. Okay, but basically to this is development of trending between nation creating a need of measurement standard. Okay, if we compare to the standard of the developed nation, okay, that they are actually they are the leading country. They research very good in certain area, and then they invent the certain standard. So if you look at the different country, that is a developed country, they have their own standard. Okay, so in Malaysia we have our standard. Okay, so that in the organization of Sirin. Okay, the Sirin. So let's say you have a device. Okay, you create a device, you have a product, so you need to certified by a certain standard. So Sirin in Malaysia used to certify for the standard. Okay, in terms of verification of, let's say you have a plug in your house, so there is a verified, okay, endorsed by the Sirin. Okay, there is a shop sealed by Sirin. So in order to uh, legalize, in order to sell in Malaysia. So every must be standardized, must be endorsed by Sirin. Otherwise, the weekend up of the device due to the safety or something. Okay, and in the US they use a NIST. It's a standard for the body to look at the safety, the measurement, okay, from the instrument. Okay. So and then we go for the standard of length. I don't want to talk about much about this one. So maybe you can read the standard of length, okay, from the history. Okay, what they use, basically the length is basic the benchmark of what. Okay, please read. And also we have the different unit of measurement of length. So we have meter, inches, we have yard, we have mile. So and then we have the standard unit, the SI unit used in the whole world. Okay, for the standard unit, basically the standard unit they use in the scientific ways, okay? Because of the scientific, we need to standardize the unit, okay? So please look at the standard unit, okay? Okay, in terms of mass, in terms of length, in terms of many, okay? So and then the conversion unit from the meter to inches, okay? So this one we are not covered of the American American unit, but American unit they use like on yard, mile or something. So we in Malaysia basically we use a British unit, which is in the standard unit. Okay, we have meter, we have centimeter, we have millimeter. Okay, others we have standard of mass. Okay, we have other standard they use is pound. Okay, basically in US. Okay, and then time basically the benchmark of the standard of time to the duration of cycle of radiation corresponding to the transition between two level of fundamental. The standard of everything basically is not come from the thin air, so they basically they benchmark to others. Okay, so in this case of time, they compare the time is a cycle of radiation of the cesium 133 atom. Okay, and then we have the standard of temperature. Okay, this one is basically the temperature. If we talk about temperature, is we don't have any uh, uh, just for the value of uh, hot or not cool or something like that. So in this temperature, there are several measurement temperature unit. Okay, in Celsius, Fahrenheit, in Rankine, the intangible or conversion unit from the Fahrenheit to degree Celsius, from Fahrenheit to absolute zero, from Fahrenheit to Rankine or something. So and then we have Kelvin. Okay, basically different between after this we have one topic discussed on temperature. So later on we will discuss more on detail. Okay, the history or from the what is the different Kelvin, Rankine, other temperature measurement, okay, and the conversion unit of measurement of the temperature. And then we go for the unit and dimension. For the unit and dimension, it basically we know about the unit. Okay, we have meter, unit in meter, unit in centimeter, unit in millimeter, unit in kilogram. So unit uh, in second, microsecond or something. So you everybody know about it. So and then we have a dimension. Okay, dimension is basically in this course we not covered more on dimension because dimension covered in the I think in the uh, uh, okay, so that dimension are used in the way to convert, okay, to get the unit in by using a dimension. Okay, so and then we have the derivative unit. Let's say we have derivative quantity, which is velocity volume produced by the basic quantity, which is mass, which is time, which is length, and then it will become a derivative quantity. And also we will produce a derivative, okay, like meter per second squared, or we have meter cube, meter, and then we have uh, Newton or something like that. Okay, so that's a derivative unit. Okay, and we have a basic unit, we have derivative unit, we have basic quantity, we have the derivative quantity. So this area is a quantity. This one more specific is derivative quantity. This one is a unit, not unit. This one is this basically we have a velocity. The unit is meter per second. Yeah. For the value, we have a meter cube. Okay. For the density, we have a meter per we have a mass kilogram per meter cube or something like that. So this one is a derivative unit. Okay. So and then we have a conversion unit from uh, the value of the given velocity in meter per second or centimeter per second need to convert to meter per second. Okay, everything is not in standard unit. We need to convert to the standard unit. Okay, so how to convert is basically you already know. So you need to convert. Okay, and then this is one conversion unit. So we only learn about the standard unit. So if given need to convert from the standard unit to feet to mile or something, we are given the conversion. Okay, let's say 1 miles is equivalent to 1.609 kilometer like that. So if the conversion unit need to convert to other not from the SI unit, so we will give the value, okay, for you to convert. Okay, and then system of unit, kita ada base unit, and then we have multiple units. Okay, this one you need to look by yourself. Okay, this one is already know. Okay, we have base unit, SI unit, and then derived unit, and a lot of derived unit we produce. Okay, from the basic unit, the combination of basic unit, we will produce a derived unit. Okay, and derived quantity. Okay,